Hello everyone. Previously, we discussed the factorial experiments. In a factorial experiment, we have more than one experimental factor. Each has more than one level. The total number of treatments is the number of all combination of the levels of these experimental factors. These treatments are randomly assigned to experimental units according to the chosen blocking design. However, what would happen when one of these factors require a bigger experimental unit than the other factor? These are the aims of the lecture. Let's start with an example. This is a 2 by 2 factorial experiment. There are 4 treatments in this experiment. There are 12 experimental units. A possible RCBD layout, do you see any possible practical problem with this design? In this experiment, the irrigation treatments could cause a problem. Irrigating one plot may influence neighboring plots, and the irrigation equipment is most efficiently used in a large area. Due to this problem, we cannot use a 2 by 2 factorial RCBD. We have to use a split plot design. In a split plot design, the factors are categorized into the main plot and the subplot. The level for the main plots are applied to a large whole plot. The level for the subplot are applied to smaller subplots within each main plot. Like factorial designs, split plot designs are treatment designs, so they are used in conjunction with a blocking design. For the irrigation and fertilizer experiment, irrigation treatments are applied to the main plots, and fertilizer treatments are applied to the subplots within each main plot. Split plot designs typically used because of the logistical restriction, practicality, or efficiency. A split plot design may be used when each level of this vector would be allocated a large unit and then divided into subunits for each level of the other vector. Treatment for this first vector could be randomly assigned to the whole unit. Each vector that required to be compared with greater precision could be randomly assigned to the subunits within the whole unit. This design required two stages of randomization. Randomization of the main plot and randomization of the subplot within the main plot. In split plot experiments, variation among subplots is expected to be less than among the main plots. Therefore, a subplot is used for the vector that either require a smaller amount of experimental material, or is major importance, or is expected to exhibit smaller differences or require greater precision. We use main plot for vectors which have major effects or which we are less interested. Since its main plot accommodates all levels of subplot, the main plot is a block for the subplot. Differences among these blocks are confounded with differences among the levels of the main plot. Therefore, a split plot design is sometimes considered as an experimental design in which certain main effects are confounded. Main plot error is the difference between main plots treated alike. Subplot error is the difference between subplots treated alike. We use main plot error to test for the effect for the main plot vectors, and subplot error to test for the effect of the subplot vector and the interaction between these two vectors. For an RCBD with R replications, factor A as the main plot with A level and factor B as the subplot with B levels, the skeleton ANOVA The linear model. Similar to the factorial experiment, in split plot design, we must test for the interaction first. If there is a significant interaction at a significance level alpha, we cannot test the subplot and the main plot. If there is no significant interaction at a significance level of alpha, we can test the subplot and the main plot. In split plot design, we have two sources of residual, main plot error and subplot error. We use the subplot error to calculate the f-test for the interaction and the subplot. We use the main plot error to calculate the f-test for the main plot and the blocks. For split plot design, we can calculate the coefficient of variability for the main plot and the subplot. For the main plot, for the subplot, to be able to compare two estimated effects, we need their standard error. In the one-factor ANOVA, we use LSD procedure to compare any two treatment means by taking the mean square error as an estimate of the population variant. In a split plot design, we may compare any two means of vector A or any two means of vector B or interaction means. The standard error used for these comparisons are different. Let's see an example. It is a split plot experiment with RCBD. The main plot is insecticide sprays because insecticide spray requires a large area. The subplot is the three varieties. The number of treatment is 6. And the number of experimental unit is 24. The possible experimental layout. The skeleton ANOVA. The interaction plot. Based on this plot, we can see a possible interaction between the variety and insecticide spray. As a default, any software will only provide one residual or error term. For SplitPlot, we must specify the term for the main plot error, which is blocked by spray interaction. The ANOVA table. In this analysis, there is significant interaction at 5% significance level. Hence, we cannot test for the main factors. Note that the F statistic for spray is incorrect, as it is calculated using the mean square of error B. For the main plot factor, F statistics is calculated using the mean square for error A. Split plot can be extended to multiple split. Let's see an example. Now we have three factors: irrigation, insecticide spray, and varieties. And we have 12 treatments. Let's assume this experiment will be conducted as an RCBD with 3 blocks. So we have 36 experimental units. In this case, we have to do 3 stages of randomization. First, randomize the main plot's irrigation within each block. Second, randomize the subplot spray within each main plot irrigation. And lastly, randomize the subplot variety within each subplot spray. The skeleton ANOVA. Because we have 3 error mean square, for the F statistic, we use as the denominator. Each level of subplot can only occur once in each main plot. As a default, there is only one residual term in ANOVA. This residual is the error for the final split, the subplot or the sub-subplot. So, for a split plot, we must include the term for main plot error, while for a split plot, we must also include the error term for the subplot. As a default, the F statistics are calculated based on the residuals. For split plot and split plot, the F statistics must be recalculated using the appropriate error terms. Now, can you do this?